Audible, sir.
Okay, madam. A very good morning to all the participants. We would like to thank our beloved director, principal, Chaitra madam, and other fellow faculty members for arranging this wonderful and useful FTP. I also welcome Dr. P. Nagesh, Dean Management Studies, KSS University, Dr. Sridevi Pulanur, and Dr. Sindhu Bharat, who are also presenting in this. Just a minute, let me share the slide. Can you see this slide?
Yes, sir. Yes, sir.
Okay. We will be discussing about sampling design. All of us know that research is a very vast and even experienced people, they don't know the full depth of the, I mean, we try to learn, but there is always something is missing. And sampling is comparatively easier topic. I mean, that's what we feel when we study research. But even people who feel they are good in sometimes the basics are not clear to them. Okay? So my idea in this FDP is to make the basics clear to everyone who are present. Okay? So you can interrupt me at any time during the session, and I may try to be interactive during some of my discussions. Okay? So what is sampling? Sampling is the process of selecting a few from a bigger group as a basis for estimating the prevalence of an unknown piece of information regarding the bigger group. From the bigger group, we are trying to source the information using a smaller, so that is sampling. We all know that most of you would have taken this subject already for students. Anyhow, let us go to the next one. The first thing is, let us see some of the basic terminologies used in sampling. First one is population. So the families in the city or the voters from which you select sample is the population. Population is the total number of units or people or whatever unit you define in the units. Total number of, for example, if you analyze it, it will be the total families in the city or town. And what is a sample? Sample is the small group of families or electors. I have taken electors, that is, they are very familiar with election analysis. Okay, we call them psychologists. They give exit poll prediction and other things. And it is one of the very interesting field to conduct, to know. Families or electors from which you collect the required information is the sample. Sample size. Sample size is the number of families or electors from whom you collect the required. For example, the population will be 1 lakh. Suppose you are going to sample only 1,000. That would be the sample size. Design and
Hello, sir. ಏನಾಯ್ತು ಸರ್ ಅದು ಗೊತ್ತಿಲ್ಲ ಸರ್ ಒಂದೇ ಸರ್
you select the factors. This is
ಅಲ್ಲ ಸರ್ ನೀವು ಹೇಳ್ತಾ ಇದ್ರಲ್ಲ ಒಂದೇ ಕಟ್ಟಾಯ್ತು
out of 1 lakh people. Choose the 1,000 people you have decided to take. And next one is sampling unit or sampling unit. Each family or elector that forms the basis for selecting your sample is called as sampling unit. Suppose I am taking a sample of college students. Each one student is called as sampling. Then sampling frame. Sampling frame is the list of sample from the population. For example, you have taken the 1,000 people whom you have to interview. Then these list of 1,000 people are called as the sampling frame. Then sample statistics. your findings based on the information obtained from the sample is called as sample statistics. And population parameters are the estimates arrived from the sample statistics. Example, population mean. Okay, so let me repeat it. Population is the total people who are going to with whom you are interested in conducting the research, and sample is the small group of families you select. Sample size is the number of people who are going to be selected. Sampling design is the way you are going to select the families or the units. And sampling unit is the single person, single unit of the sampling frame, means the list of sample from the population is called as sample statistics is the data you get from the analysis. Population parameters are the estimates arrived from the sample statistics. Okay? We should be very clear with these basic terminologies, because it's likely that you get confused when you actually do the research. And next one is, as I have already told you, many of us we do write papers and we do sampling. Sometimes we don't get the full grasp of the principles of.
ಅವ್ರಿಗೆ ಎಕ್ಸಿಕ್ಟ್ ಆಗಿದ್ದೆ ಗೊತ್ತಾಗಿಲ್ಲ ಅಂತ. ಇವಾಗ ಬಂದಿದ್ದಾರೆ ಮತ್ತೆ JSS.
I have taken this from a wonderful book.
ಮತ್ತೆ ಏನ್ ಮಾಡೋದು ಆಮೇಲೆ ಹೇಳ ನಾ ಇವ್ರದಾದ್ಮೇಲೆ ನೀವು ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀರಾ ಅಂತ ಅಲ್ಲ ಇನ್ನೂ ಸ್ವಲ್ಪ ಇದ್ರೆ
different. So principles of sampling.
ಇಲ್ಲ ಇವ್ರದಾದ್ಮೇಲೆ ಸ್ವಲ್ಪ ಹೇಳ್ತೀರಾ ಅಂತ ಕೇಳಲ್ಲ.
In a majority of cases, there will be a difference between sample statistics and the true population. Let me repeat it. In a majority of cases, there will be a difference between sample statistics and the true population. For example, assume there are 50 students in a class having height between say 150 to 170 centimeters. If you take the overall average, you might get 160 as the average. But you get any 3 or 4 as sample, you might get 155 or 165 as the average. Okay? So there is a difference between sample statistics and the true population. So I have explained, I have tried to show this using this slide. You can see age of employees. Assume there are 8 employees in the department. So A, B, C, D, E, F, G, H. And the age, say between 22 to 28 is differing. And the mean, if you work out, it comes to 25.5. This is the population mean. Okay, population mean. The 8 people, so we are able to calculate the remaining 18. So the mean is 25.5. Assume you select a sample of 3 randomly.
ಏನಾಯ್ತು ಅಂತಾನೆ ಗೊತ್ತಾಗ್ತಿಲ್ಲ ಅಂತ.
A, D,
ನಡೀತಾ ಇತ್ತು
average or mean. It is coming to 24.66. Whereas the population mean is 25.9. This difference of around 0.84 right here. This difference of 0.84 is called as sampling error. You might have seen sampling error. So I wish I have cleared what is sampling error is the difference between sample statistics and the
Sir, voice is not audible.
Sir, voice is not audible, sir. Vishwanath sir. ಸರ್ ಸರ್ ವಿಶ್ವನಾಥ್ ಸರ್ ಆದಮೇಲೆ ಹಲೋ ಸರ್ ವಿಶ್ವನಾಥ್ ಸರ್ ಆದಮೇಲೆ ಏನಾದರೂ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀವಿ ಸರ್ ಹೇಳ ಹಾಂ ಲೆವೆನ್ನಿಗೆ ಮುಗಿಸಲ್ಲ ಸರ್ ಅವ್ರು ಭಾಳ ಇದೆ ಅನ್ಸುತ್ತೆ ಇನ್ನು 11:15 ಮುಗಿಸ್ಬೋದು ಅವರು ಹಾಂ 30 ಎಸ್ ಸರ್ ಸಿಂಧು ಮ್ಯಾಮ್ ಹಾಂ ಹಾಂ ಯಾಕೆ ವಾಯ್ಸೇ ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ಹಲೋ
Oh God. Hello? Am I audible now?
ಯಾ ಸರ್ ಆಡಿಬಲ್
It was not audible, madam?
ಇಟ್ಸ್ ಆಡಿಬಲ್ ಸರ್ ನೌ ಇಟ್ಸ್ ಆಡಿಬಲ್
What? Okay. Sorry for the interruption. So let me go to the principles of sampling again. See, the first principle is, in a majority of cases, there will be a difference between sample statistics and the population mean. So we have taken this example of 8 employees and the ages are given. If you take the mean, it comes to 25.5. 25.5 is the population mean. We assume 8 is the population mean. Suppose you are taking
Hello,
a
sir.
sample of 3 people, say A, B and F. You will be getting the average as 24.6.
ಹೌದಾ ಹೇಳ್ತೀನಿ ಸರ್
This difference of 0.84 is called as sampling error. That is error through population mean. So the second principle is, the greater the sample size, the more accurate the estimate of the sample mean. If you take more people in the sample, then you will be getting close to the population mean.
ಸರ್ ನಾಟ್ ಏಬಲ್ ಟು ಹಿಯರ್
So in the
ವಾಯ್ಸ್
same example,
ಇದು
now we
ಹೇಳಿ
are
ಸ್ಟಾಪ್
taking samples. Assume we are taking B, C, D, E, and F. Then the mean
ನಮ್ದು
would
ವಯಸ್ಸು
be
ಮ್ಯೂಟ್ ಆಗಿದೆ ಆ
25.
ಡಗಡಗ ಏನು ಬರಲ್ಲ ಇಂಟರ್ನೆಟ್
This
ಅಂತ
value is close to population.
ನೀವು ಕೇಳಿ ಗೊತ್ತಾಗತ್ತೆ ನಿಮ್ಗೆ ಬರ್ತದೆ
So always when you take
ಅವ್ರಿಗೆ
a
ಅವ್ರ ಸಂಬಂಧ
sample
ಅವ್ರು
size,
ಇಟ್ಟು ನಿಮಗೆ ಕರೆಕ್ಟಾಗಿ ಕೇಳ್ತದೆ ಅಂದ್ರೆ ಎಲ್ಲರಿಗೂ ಕೇಳೋದು
ಹಾಂ ಕೇಳಿ
ಫಸ್ಟ್ ಅವ್ರ ಪ್ರಾಬ್ಲಮ್ ಇಂಡಿವಿಜುವಲ್ ಪ್ರಾಬ್ಲಮ್ ನೀವು ಅದನ್ನ ಅಡ್ಜಸ್ಟ್ ಮಾಡಿ
and the third one is principle 3. Principle 3 is, the greater the difference in the variable under study in the population for a given sample size, the greater the difference between the sample statistics and the true population mean. See, in the earlier example, we have taken age between 22 to 28, okay, in a narrow range, that is about 6 years of difference between the youngest employee and the oldest employee. But in this example, suppose you take the 8 employees age between 22 to 39. The population mean would be 29.5. And if you take the same kind of sample, okay, ADF, you will be getting the mean of the sample as 26. What it means is, the variable what you are analyzing, if the difference in the variables are sharp, I mean, if it is more, then there will be, the greater the difference in the variable and the study in a population for given sample size, the greater the difference between the sample statistics and true population. So when there is a wide difference between the variables under study, you will find the sample error high. Okay, that's what the principle 3 means. Understand these three principles clearly. Keep in mind when determining the sample size for accuracy and for selecting the right sampling strategy. Okay? So all these three sampling rules are very important. Let us recap. First one is there is a difference between population mean and the sample mean. This is called as sampling error. So be clear about that. And second one is if you increase the sample size, the sample error. When you increase the sample size, sample error will decrease. Next one is if the variable under study are very different, then the sampling error will be high. So you should take homogeneous population for sample. In other words, we will discuss that later. Standard error to calculate because statistics is a bit complicated. For your understanding, I will just tell you what is standard error. Let me read the same example what I have given in the slide. Wants to study the type of sample used by college students in Bangalore, and if the number of college students are say 1 lakh, and you take a sample size is 1%, you will get some data. Okay, so you have certain parameter for this first sample, which is 1% of the population of college. Assume that similar research is done by another person. He will be selecting another sample, say the same 1%. If one more person is doing, he will also collect some sample. The difference between these researchers who are doing independent research is called as standard error. This also be clear. And you should know the difference between sampling error and the standard error. Standard error is the error when you conduct the research, when similar research is conducted by 2-3 different researchers. And for this also, there are certain calculations. We can approximate this standard error, but as I told you, in this half an hour, it won't be possible to cover. But there are formulas, there are certain basic rules how to find out standard error. That you will be, you can learn it. Then I want to discuss one more thing as one concept called as homoscedasticity. Read it and explain. Sample population must have the same variance as that of the overall population. Sample population must have the same or similar variance as that of the overall population. You know the way, what is variance? Root of variance is the standard deviation. This is called as homoscedasticity, and this is a basic requirement for parametric. So I just want to ask you, can someone tell me what is a parametric test? I just want to know some of the research scholars, can you throw light what is a parametric test? Hello? Would someone like to share parametric test? Okay, so this is basic requirement for parametric test, and I assume that most of you know what is parametric test, but even otherwise let me explain. Parametric test is a test which can be conducted only on a normal distribution data. Okay. The basic assumption is the data should be normally distributed, then only we can conduct So this is important, and this is called as homoscedasticity in the sense so you have 1,000 people, the variance of the 1,000 people and the variance of the 1 lakh should be somewhat similar or same. If they are very different, there is something wrong. It means you have taken the wrong sample, and you will not be eligible for doing parametric test. As we are discussing about the how to write a technical paper. See, even I have done, you'll be knowing some good journals, they send the papers for expert review. I had been a reviewer for 1 or 2 papers. We reject the paper immediately when you find parametric tests are being used for non-parametric tests. Okay, so it is very simple. But he collects non-parametric data, and if they use parametric test, we outright reject the paper. So you should be careful what kind of data you collect, what kind of sample you take, and what kind of test you use. In the limited time we have, I will try to give you some light on that. Characteristicity is when the sample population has the similar variance as that of the overall population. It is called as homoscedasticity, and this is one of the important concepts in time series econometrics also. They will be, econometrists will be using this concept very quickly. Next, let us see what are the characteristics of good sample. Sample is a true representative of the population. So that's what we said, homoscedasticity. The population and the sample should be similar and free from the error bias. Bias could mean you are taking random, you are just taking samples without any proper strategy. And adequate in size for being the sample should be adequate in size for being reliable. I think we'll be knowing the concept of reliability and validity. Reliability is the same test when repeatedly applied should also give the same kind of result. And validity is when whether you are measuring the same thing what you intend to measure. So when you have good size of sample, then your sample will be reliable, and units of sample should be independent and relevant. That is, no intermixing of sample units between samples, and units of sample should be complete, precise and up to date. Right. Then how to select a sample from the population? I think our previous speaker also touched on this. So suppose if you take an example, study to ascertain the needs of young people living in Bangalore, we have to define what we are going to study. Okay? First, clearly and precisely define sample. Because when you say need of young people living in Bangalore, it does not define it. First, you have to define whom you are referring as young people, whether you mean 15 to 18 or 18 to 21, 22 to 25, 25 to 30, you mean adolescent or late 20s. Okay, so you should be very clear in defining young. You should clearly define male or female. Okay, for example, if you say a study to ascertain the needs of young women aged between 18 to 25 living in Bangalore, that is the correct definition. You can ask just to say a study to ascertain the needs of young people living in Bangalore. Suppose we give a topic like this, the definition of the young should be given in the paper. if you don't define the n, then your paper will be substandard. Okay. So to put it lightly, so you define the population very clearly. There should not be any ambiguity in it. Okay. Next is the sampling design process. So you define the population first, then determine sampling frame. I have told you what is sampling frame. Sampling frame is the list of samples. Okay. Then determine sampling procedure. You can use probability sampling and non-probability sampling. Concept called parametric test. Parametric test means use of normally distributed variables. Okay. So if you are collecting normally distributed variables, then you can use probability. If you want to collect normally distributed variables, then you can use simple random sampling, stratified sampling, cluster, systematic sampling, and multi-stage sampling. That systematic sampling is sometimes called as mixed sampling. Okay. Then under non-probability sampling, we have convenient, judgmental, quota sampling, snowball sampling. Then determine appropriate sample size. Then executive sampling. Okay. Again, the question comes: how will you calculate the sample size? Okay. So you have a lot of good softwares. I mean, in net it is easy to get the determination of sample size. But the problem is you should understand the basic statistics first. The statistics is a bit complex in the sample size determination. This is out of scope in our today's discussion. But it is, if you understand what is confidence interval and other concepts clearly, you can calculate the sample size. But please always remember, the logic should be proper when you are calculating the sample size. Again, in quantitative studies, the sample size is very, very important. In qualitative studies, sample size is flexible. You can be little lenient. So let us see what is probability sampling. Probability sampling scheme is the one in which every unit in the population has a chance of being selected in the sample, and this probability can be accurately determined. So let me explain again. Suppose you have 50 students in a class. You want to select 3 people. All the 50 in the class should be eligible for selection. Okay. In the sense, you can use fishbowl method. That is, you would have seen, no? Glass bowl, they will take and put all the names, and you will pick randomly 3 people. If you do that, it is called as probability sampling. The other, I mean, the actual meaning is every one person, suppose there is a class of 50, every one person in the class has the 1/50th chance of getting selected. Okay. So if the number is 50, the person getting selected, the probability of the person getting selected is 1/50. I think you will know that that is the probability calculation. And this brings us to the question. See, first person you are selecting is having the probability of 1/50. Suppose you select the second person, what will happen? The probability will reduce to 1/48. I mean, it will increase to 1/48. If you select the third person, the probability will be 1/47. So when you do that, this is called as sampling without replacement. Okay? It means you are actually that won't come as probability sampling. That is, every person should have equal chance in the selection. So what you have to do is, you select one person, and after selection, the same name should be put in the bowl again. Select once more. Suppose you get another person, okay. If you get the same name, Again, you discard and take again. The probability 1 by 50, that is the idea of probability sampling. Okay, so that you keep in mind. This is called as sampling with replacement and sampling without replacement. And please remember, sampling with the replacement is always better. And okay, so probability sampling, you identify the universe. When every element in the population does have the same probabilities, known as equal probability of selection. That's what I was explaining to you. The probability of selection should be same for all the units. So are also referred as self-weighting because all sample units are given the same. So when you do probability sampling, you can use only parametric. So statistics. Yes. So when you do probability sampling, you can apply only parametric test. I have already told you what are parametric. I mean, you'll see that. Then simple under probability sampling, we have some methods. First one is simple random sampling. As I told you, this fishbowl example is a simple random sampling. The merits is no personal bias, representative of the population. And if the population is 1 lakh, how can it be? So that is a demerit. And it requires completely cataloged universe. And there are random numbers method and other things are also. So that is simple random sampling. And second one is stratified random sampling. Under the stratified random sampling is a method of probability sampling in which the population is divided into different subgroups and samples are taken from each of them. Applicable when population is large and heterogeneous. For example, say you are studying about 10 people, there could be male, female, age, different group. You can separate them differently, call them strata. And each strata you select people based on random sampling. That would be a stratified random sampling. And merits, it provides better coverage of population, and it is greater precision, and it saves money, and you can do separate analysis for any subgroup also. And demerits, sampling frame for each strata you should put that is called demerit. And when examining multiple criteria, stratifying variables may be related to some but not to others. That is, when you are doing different strata, and the analysis might become complicated because some will be, for example, for women and for men, there could be mutually exclusive traits, mutually exclusive data. Okay, so that will be a problem. And when you use stratified random sampling, this sample size should be definitely larger than simple random. And next is cluster sampling. Cluster sampling it cuts down the cost of preparing. I will explain cluster sampling. For example, you want to analyze all the colleges in Karnataka. You cannot do all the colleges. So what you do is you can cluster them into different regions. For example, Bangalore, Davangere, Mysore, etc. And in each cluster, you identify 1 or 2 colleges and do full census survey in that. Then it would be called as cluster sampling. Later, I will show you one example. Then you will understand. So that is cluster sampling. And stratified cluster sampling is also similar to cluster sampling, but within clusters there will be strata. Then we have something called as systematic sampling. Systematic sampling, I will give you an example, then you will understand easily. For example, if I take a certain group and I select every 20th person or 40th person, something like that. That is called as systematic sampling. In some books, this is referred as mixed sampling. Okay, that is, we use both random probability sampling and non-probability sampling. So, depending on your need, you can use it. And multi-stage sampling, this is complex form of cluster sampling in which two or more levels of units are embedded in one or the other. So first stage, as I was telling you, random number of districts is chosen in all states. Or say we are choosing colleges in Karnataka, we can pick some districts on random basis. Then in each cluster, we can follow the same random method to allocate or to select villages. Then third stage, in the villages, you will select houses. Okay? And the ultimate stage, suppose you take one township or one area, then all the houses in the area should be surveyed. That would be your multi-stage sampling. Sorry, no time to discuss all this as we have to Rakshan. So let me go to non-probability sampling. So when you say non-probability sampling, we know that each unit will not have equal probability. Okay. So one person will get the answer. When you do that, it is called as non-probability. Okay. So the explanation is here. Every element in the universe does not have equal probability of being chosen in the sample. And the universe is unidentified. Sometimes you may not define the population also clearly. That's what it means. Then it involves the selection of elements based on assumptions regarding the population of interest, which forms the criteria for selection. And hence, because the selection of elements is non-random, non-probability sampling not allows the estimate. You cannot measure the sampling error because you are not taking sample in a uniform basis. Okay, the samples are not uniform, so there is no question of sampling error. That's what it means. Then only non-parametric test can be applied, and the results may not be generalized. Generalized in the sense it is applicable only for the particular group you are doing the research. And again, I am telling you, if you are using non-probability sampling, you should use only non-parametric tests. Okay, like Kresker-Wallis and other tests are there. If you do it wrongly, if you use non-probability sampling and if you use parametric test, your paper is likely to be rejected. Whether it is, when it goes to peer review or when it goes to inspection UL, they will easily identify your concepts are not clear. So non-probability sampling includes convenience sampling, quota sampling, judgmental sampling, and snowball sampling. So what is convenience sampling? And whichever is convenient to you, you select it. Okay, so there is no use of probability, no use of judgment. You just select whichever is convenient, and the merit is it is useful in pilot studies, and demerit, when you use convenience sampling, the results are always biased, and then the other one is quota sampling, most commonly used in non-probability. It is quota sampling is nothing but to segment the population as mutually exclusive subgroups, just as in stratified sampling, and from there you select. For example, mutually means in relation to group and the other group. Then from each group you select based on your judgment. Then judgmental sampling, the other names are purposive sampling and deliberate sampling. Exclusively on the judgment of the sampling, people selected which investigative tanks are. So suppose you are the researcher or you are doing say, study on HIV patients or leprosy patients, you can judge which person to take. Then that would be judgmental sampling. For example, you can say a person having 5 years of disease, I will select. So then that would become a judgmental sampling. See, this is used primarily where there is a limited number of people that have expertise in the area being researched. Okay? So, as I told you, in medical research, this is used here. Next one is snowball sampling. Snowball sampling is when you see, for example, you want to find out somebody using a special perfume. Okay, you may not get the data so easy. What you will do is you will find out one person first, and after interviewing him, you will ask whether he knows anybody else who is using the same kind of perfume. If he refers someone else, then you will go to the other person, you will interview him, and do his. It is something like the multi-level marketing, where one person leads to other person. That is called as snowball sampling. It is a special non-probability method used when the desired sample characteristic is rare. And the research starts with the key person and produce the next one to become a chain. It is just something like the chain marketing. Remember, snowball sampling is something like the chain marketing. One person leads to the other person. Okay. So I think I have just given you some light on basic concepts. Now there are some questions. I just want to please read it. Let me ask a question. Let us see whether we get the answers right. Okay. So let me ask the first question. The student council surveys 100 students by getting random samples of 25 first year, 25 second year, 25 third year, and 25 PG students. Okay. What would this sampling method be? Someone knows, they can answer. Okay. So let me read all the questions first. Second one is, an airline company wants to survey its customers one day. So they randomly select 5 flights that day and survey every person on those flights. The airline company wants to survey its customers one day. So they randomly pick 5 flights that day and survey every person on those flights. Okay. That is, you pick some people, you pick some groups, and you do full survey. If somebody knows the answer, you can tell me please. Okay.
Stratified random sampling.
Which one, ma? First or second?
Second one, sir. Stratified random.
Second,
Systematic it is.
stratified. Okay. First one,
It is systematic.
which is
So
systematic?
for second one,
Which is systematic?
second one, because they're selecting a 5 flights on a random basis, so it may be systematic. Because systematically we need to go ahead.
Okay. Let us see. Let me answer. Okay. Third one, the teacher puts the student's name in a hat and chooses without looking to get the sample of students. Like the fishbowl method, teacher puts all the names in a hat and she randomly puts some names. What is this? What is this?
Simple random.
Simple random. Okay. So this is very clear. Very good. The third one is simple random sampling. And fourth one, the principal takes an out of students' names and picks a random starting point. Every 20th student is taken in the survey.
It is systematic random.
Fourth is,
It is
okay,
also
right.
systematic.
Let
It
us
is
see the,
systematic random.
okay, let us see the answer later. And the fifth one is, school chooses three randomly selected athletes from each of its sports team to participate in a survey about the athletes at the school.
It's a quota sampling.
Uh,
Quota.
It is a stratified sampling techniques.
No false.
Stratified random sampling.
okay. Okay, let us see the answer. The first one is simple random sampling. Okay. Council surveys 100 students by getting random samples of 25 first year, 25 second year, 25 third year, and 25 PG. This is a simple random. And second one is, as we have seen, it is cluster sampling. See, please remember, reading in the book and understanding cluster sampling is slightly difficult. So you remember this example. An airline company wants to survey its customers. It randomly selects 5 flights, and every passenger in the flight is interviewed. So you remember this example, it will be useful for you to remember cluster sampling. So this is cluster sampling. That is, you pick some 3 or 4 randomly. Suppose you take some 10 buses randomly and interview every passenger in the bus. That is a cluster sample.
Hello.
Yeah.
That flight, one flight we consider as a group because in a cluster we take it into consider group, right? So the flight we considered are any, as you say, the 5 flights we make it as a group of one.
Pardon?
Because the flight, your 5 flights are considered. The one flight we have considered as a group because a group of people in a flight we consider one group of 5 groups and we make a survey on
Yeah,
this.
they will be considered as a cluster. Correct.
So that's the reason it's called a
Right.
cluster. That's what I'm asking.
Yeah.
Because in a cluster we have a group,
So
right?
this
Like,
see, cluster means it is a mixed group of people. There is no homogeneity.
yeah.
Okay. So please remember cluster of people. Everybody in that cluster. Okay. You census survey in the and there is a thin line between each method. Right. The third one is a teacher puts student's name in a hat and chooses. That is very obvious. It is simple random sampling. A principal takes an alphabetical list of students' names and picks a random starting point. Every 20th student is taken. Okay, you might think that is random sampling. No, it is a systematic sampling. Okay, because there is no homogeneity in the group. Right, every 20th student is taken. That's why I have given you some examples. And if a school chooses 3 randomly selected athletes from each of its sports team to participate in a survey about the athletes at the school. So it is stratified random sampling. So you are choosing 3 athletes from each of its, for example, there are 3 teams. You are selecting, say, assume there are 5, suppose there are 5 teams. From each team, 3 people are randomly selected. That's why we call it as stratified random sampling. Just remember this. Okay. Finally, points to remember. So the first point is accuracy of your research depends on your sample selection. The objective of sampling is to minimize the gap between the sample values and population value. In other words, reducing the sampling error. And third one is the basic premise is that a relatively small number of units, if properly selected, will reflect the population. So what we are trying to get is from 5 or 10 people, we want to get the 100 people's OPT or 100 people's some statistics. That is what we are trying to get. Sample and sampling strategy will influence the statistical test that can be applied to the data. As I have already told you, it is easy to find whether the paper is good or not by just checking the test you have used and the sampling technique you have followed. If there is a mismatch, then it means your paper is wrong. Then sampling with replacement is always better than sampling without replacement. I have explained to you what is sampling replacement. That is, the probability of each unit in the sample getting selected should be the same. Okay? That is sampling without, with the replacement. That is, you in a fish bowl, you put the names, you select one name, then after selecting the name, you put the name again in the bowl and again select one more. Okay? Then that would be sampling with replacement. Then when your research paper thesis goes for expert review, the experts can be, okay, I have already told you. And a reasonably good sample based on scientific methods will reduce type 1 error. You will be knowing what is type 1 error, that is rejecting the null hypothesis when it is true. To avoid that, you should have a good sample and reasonable sample size. You can avoid type 1 error. And thank you.